For decades, the standard nutritional advice has been absolute. Human beings need carbohydrates. We are taught that without them, our brains stall, our energy crashes, and our bodies simply cannot function. Government guidelines typically recommend at least 130 grams of carbohydrates a day just to survive. But for high-performing athletes, this rule is pushed to the absolute extreme. Elite competitors are often advised to consume upwards of 1,000 grams a day, constantly refueling to maintain peak physical energy. Recently, researchers decided to test this dogma. They synthesized over a century of clinical data and randomized control trials, specifically examining athletes who follow these massive carbohydrate regimens. What they found defied all expectations. Among middle-aged competitive runners, people with lean body weights and exceptionally high fitness levels, up to 30% were developing prediabetes. These athletes exercise relentlessly and carry almost no excess body fat. They are supposed to be completely immune to metabolic disease. Yet the very fuel they rely on is driving their bodies into a state of chronic illness. The modern fixation on carbohydrate loading actually traces back to the 1960s. Scientists developed a new biopsy technique to extract and analyze human muscle tissue. Inside the fibers of active athletes, they discovered chains of stored glucose, known as glycogen. When athletes ate more carbohydrates, they stored more glycogen and seemed to run longer. The scientific community assumed a direct cause and effect. They concluded that cramming the muscle with glycogen was the single biological requirement for human endurance. A modern analysis of 160 sports studies reveals a different mechanism. When athletes exhaust themselves and hit the wall, it has almost nothing to do with the amount of glucose left in their muscles. The true limit on physical performance comes from a tiny, distinct reserve, the roughly 5 grams of glucose circulating in the blood. When that specific blood sugar level drops, the brain detects an energy deficit. It triggers an immediate neuroendocrine response, releasing stress hormones that force the muscles to shut down and protect the central nervous system. For half a century, dietary guidelines focused entirely on packing the muscles with sugar. By ignoring the brain's requirements, we subjected the human body to a continuous, massive carbohydrate overload. To understand the damage of that overload, you have to look at what happens the moment you eat. Whether it is a plate of pasta or a highly rated superfood like an orange, the digestive system breaks those carbohydrates down into individual sugar molecules, rapidly flooding the bloodstream. Detecting this sudden rise in blood sugar, the pancreas acts as a biological thermostat. It responds by releasing a massive surge of the hormone insulin to manage the incoming energy. Insulin operates on a strict hierarchy. Its absolute first priority is to secure energy for the brain, so up to 75% of that insulin wave travels straight to the liver, forcing the organ to absorb and store the glucose. But the liver has limited capacity. When it is constantly bombarded by high-carbohydrate meals, insulin begins packing excess fat into the organ alongside the glucose. Over time, this specific mechanism directly drives fatty liver disease. Once the liver is addressed, the remaining insulin moves to priority 2, the adipose tissue. Insulin binds directly to fat cells, signaling to the body that there is an extreme abundance of nutrients in the environment. Because the system senses a surplus, insulin creates an impenetrable chemical barrier around the adipose tissue. It completely blocks the body from breaking down or burning its own fat for energy. Only after the liver is entirely packed and the fat stores are locked down does the sequence reach priority 3. The final, lingering overflow of glucose and insulin spills over into the muscle tissue. This strict sequence reveals why you cannot simply outrun a bad diet. Conditions like obesity and insulin resistance occur when we continuously force excessive amounts of carbohydrates through this biological triage system, overwhelming the tissues until they stop responding altogether. The human body actually has a built-in alternative. Physiologically, we require exactly 0 grams of dietary carbohydrates to survive and function optimally. Long before sports drinks existed, athletes operated on a very different fuel. Records from the 1800s show that Olympic competitors relied predominantly on diets rich in protein and fat to perform at the highest levels. Modern clinical trials confirm this. When Ironman competitors fully adapted to ketogenic, near-zero carbohydrate diets, they rode for up to 4 hours straight, with zero drop-off in their maximum performance. You don't have to be an elite athlete to trigger this adaptation. For the average person, removing heavy carbohydrates from your plate causes an immediate reaction. Within the very first 24 hours, circulating insulin levels plummet, and the body flips its metabolic switch away from sugar dependency. This kicks off a rapid 7-day cascade. Without high insulin keeping the system locked, fat cells are liberated and burned for energy. Simultaneously, the excess water weight that insulin forced tissues to retain is rapidly flushed from the body. By week 4, the system reaches a new baseline. The brain transitions to burning ketones, the constant spikes of hunger vanish, and blood pressure levels drop naturally as the excess fluid leaves the system. Our metabolic health is not dictated by complex math or sheer willpower. By simply restructuring your plate to prioritize protein and healthy fats, you can opt out of the dangerous insulin cascade, reverse metabolic damage, and reclaim control of your own biology.